Hi, Greg Bruns here with Nortec Global HVAC. Welcome to another Lunch and Learn. Today's topic is going to be heat pump startups, both with the new heat pumps and existing heat pumps. One thing I really think that we should cover, because we seem to get a lot of phone calls into technical service about it, is just basic thermostat wiring to a heat pump system and what exactly the wiring connections mean, how they're hooked up, and what they do in the function of the system. Also, outdoor thermostat wiring. We'll discuss that a little bit. And I'm talking about the addition of an outdoor thermostat, not the thermostat inside the house. Other things we're going to discuss and talk about would be heater kit wiring and operation, airflow setup, the quick reference data sheet, checking the charge and the operation of the heat pump, the defrost cycle within the heat pump. And then when we get into some of the existing stuff, we'll talk about things like best time to check the heat pump, visual inspection and looking for potential problems, and making sure the electric heat's working in an existing heat pump. And keep in mind this is a Lunch and Learn, so we're going to have a Q&A at the end of this. So as we're going through here, you're welcome to submit questions as we're going, and then we will take those questions at the end of the presentation. All right, so we're getting right into the wiring. What I have here in front of me on this iPad is the wiring schematic off of a 14-SEER microchannel heat pump. It's on page 6 of the installation instructions, figure 4. I'm just going to kind of cover what's different with a heat pump. Your G, your C, your Y, your R, that's pretty much standard in any air conditioning system. Those are pretty standard common connections, so I'm not going to spend much time in this video about that, except for keep in mind that R and C has to go out to that heat pump at all times because you have to have 24 volts for that defrost board to work properly. The other thing I want you to keep in mind is the G and Y terminals of your air handler. Remember, G being energized on that air handler is only going to be for the fan speed. When you have a heat pump heating call or you have a air conditioning call, that Y terminal on the air handler has to be energized because that is what is your cooling speed. That's what sets cooling speed, not G. G on most units anymore, on a standard blower, G is going to energize that blower to same as the heating speed, not the cooling speed. So keep that in mind. And remember, Y is what turns on the heat pump, whether it's in cooling mode or heating mode. W does not turn on that heat pump. Y turns on the heat pump. So one of the other connections we need to discuss a little bit in here that makes it a little different with the heat pump is the W2 and the E terminals and your W2 out and your W2 in on the outdoor unit. Those are the terminals that are a little bit different. So what we show here is E going to W on the air handler. That's emergency heat. So most of your better heat pump thermostats will have an emergency heat selection on the selector switch. When you select that to emergency heat, what that does is it overrides the heat pump, shuts it off. The heat pump will not function. And then it comes a single stage thermostat that energizes the E terminal and turns on and sends power to W, which turns on your electric heat. And that's the only thing that'll function is your electric heat. And it's used for when the heat pump is not working. Let's say it's froze up because it's not defrosting. So you instruct the homeowner, okay, turn it to emergency heat. That'll give you heat until we can come out and take a look at the heat pump and find out what's going on. All right, so now we're going to go back to W2. W2, what is that? W2 is essentially auxiliary. So in regular heat pump heating mode, you essentially got 2 stages to the thermostat. Your first stage is the heat pump, which is Y. That turns on the heat pump in heating mode. If for some reason that heat pump is not keeping up, then we're going to go into W2 and energize that also. W2 is going to be either W2 or auxiliary. Some thermostats call it auxiliary, so keep that in mind also. W2 and auxiliary is essentially the same thing. But on this diagram, we're showing it going outside to an optional thermostat. All HUD manufactured housing requires that we incorporate and send out with the unit a outdoor thermostat which will hold off the electric heat unless it's below, I believe it's 45 degrees, don't quote me on that. But that's essentially what it does. Is if your auxiliary heat makes on the thermostat, it's going to go out to this outdoor thermostat. This outdoor thermostat looks very similar to a limit switch because that's essentially what it's doing. It's limiting the use of electric heat. So this is the outdoor thermostat. So in that diagram, you'll see W2 goes out to this thermostat, then it leaves the thermostat and goes into the defrost board on the outdoor unit on W2N. So if you get a call for auxiliary heat, along with the heat pump running, it'll send power out to this thermostat. If the thermostat is closed, it'll go through the thermostat to the defrost board, energizing W2N. Then it's going to leave the defrost board on W2 out and go back in and energize the electric heat on the air handler. If the thermostat is open, obviously auxiliary heat doesn't function. Okay? So with all manufactured housing units that Nortek Global builds, we ship this with the branding packs because of the HUD requirement. Residential units, this is available as an accessory. I want everybody to understand that this thermostat or limit switch, whatever you want to call it, that we ship the unit has nothing to do with shutting this unit off. The only thing it does is limit the use of electric heat. The thermostats that a lot of technicians think should actually shut the unit off, they do exist and did exist in a lot of older heat pump equipment. That was a balance point thermostat. A balance point thermostat is completely different than this thermostat. A balance point thermostat would shut off the outdoor unit if it was deemed that the heat pump couldn't keep up because it was so cold outside, and it would only allow the backup heat to function once it fell below the setting of that balance point thermostat. That's kind of old school, because in today's world, you really don't need a balance point thermostat in the outdoor unit, because you can use a good quality thermostat that's got an outdoor sensor, and then you set up the thermostat to whatever temperature you want the heat pump to shut down, and then the backup heat take over. So it's pretty simple. You really don't necessarily need a balance point thermostat anymore. Okay, so now I want to talk about heater kits a little bit. We still seem to get a lot of phone calls about the new H8 heater kit. So I thought I had a great opportunity here to kind of touch on this subject again. So what I have here in front of me is an H6 and an HK heater kit, and I want to point out the differences between the two. So the H6 heater kit was the predecessor to the H8. What you'll see on here is there's only one black relay, because this is only a 5 kW H6 heater kit. If you had a 10 kW, you'd have 2 black relays. If you had 15, you'd have 3 black relays, and so on. So in the H6, that's all we had on those heater kits, is the black relays switching the power to only one side of the element, not the other side. So now let's switch up and we'll look at the H8 heater kit. On the H8 heater kit, being another 5 kW, just like the H6 I just showed you, it's got one black DC relay. The control voltage going into that relay is DC voltage, just like it was on the H6. And then you have the white relay, which is an AC controlled relay. So again, what you're going to have is, if you've got a 5 kW, you're going to have one black and one white. If you had a 10 kW, you'd have 2 blacks and 2 whites. 15 would be 3 blacks and 3 whites, and so on. Okay? Just remember, the black relays are always going to be DC control relays, and the white relays are going to be always AC control relays. And in order to get those AC control relays powered up, we're going to need the white and gray wire coming from the heater kit to W and C. And if you had a 2-stage air handler control board, it would be W1 and C. So that when you get a call for heat, W1 gets energized on the white wire, C being hot all the time. We're going to energize that white relay, and the white relay is controlling the power going into the other side of the element. The black wire going into the element is controlled by the DC relay. That's what happened here. The Underwriters Laboratory said, we can no longer build heater kits that only switch off the power to one side of the element, and that's what the H6 heater kit did. The H8 heater kit has the black relay that switches off the power to the black wire on the heater kit, and it has the white relay that switches off the power on the red wire on the other side of the element. So when the unit is off, there's absolutely no power going to that element at all. Okay, so one of the things you want to do, every time I did a fall check, one thing I always made sure I did was make sure that backup and electric heat works. So that way I knew if the heat pump wasn't functioning, and the homeowner called me, said it was froze up or anything like that, I knew I could instruct them to go to emergency heat, and I knew from my fall check that that electric heat was working. So whether it's a new startup or an existing heat pump, you absolutely want to make sure that electric heat is working. So this one here, I've already got an amp probe on the power line coming in. We're going to turn it on. I got the thermostat set to emergency heat, and as you can see from the meter here, 5 kW, we're pulling about 19 amps. That's about right. You're going to pull about 20 amps for each element that you have inside that heater kit. Like I said, it depends on the exact kW, and also depends on the voltage. So on this, the amp draw is a little bit lower because we got a lower voltage. This is 208 voltage supply coming into this building. But typically, residentially, you're going to have a 240 volt supply, and you're going to be close to 20 amps. So we can do it this one of two ways. We can check the amp draw going into the entire heater kit where this amp probe is showing right here. The other thing we can do is individually check the elements, especially if you have more than one element. So what you would do there then is you just find your wires. You can either go all the way up inside there and catch it right on the heater kit, or follow the power wire coming from the breaker to each bank of electric heat. So you can see here, we're still around 18 amps. We just don't have the blower included anymore. We're only testing the electric heat of the element. So two things you want to do here is make sure all the electric heat elements, however many's in there, that they're all cycling on. And then the second thing you want to do is turn the thermostat down and make sure it cycles off completely. Okay, so the other thing we want to do on a new heat pump startup, we got to make sure that that blower's been set up right. So keep in mind, these air handlers come factory set on low. So it's up to you as the installer to go in and make sure that that blower is set correctly for the speed that you need for whatever size heat pump you're working on. This being a 2-ton B6 MMO 24 kb air handler with an FT4BE 024 KA condenser, the blower's shipped on low. So that's going to be too low for you. So how do you make that speed adjustment? That's what I want to talk about real quick. So the red and black wires coming down to this blower assembly, go to a double spade terminal and plug on to number 6 terminal of that motor. Red is your heat speed, electric heat speed, not heat pump heating speed, electric heat speed. Black would be your cooling or heat pump airflow speed. So right now they're both going and energizing the same speed on the motor. On this one here right now it's going to low speed, but I can tell you installing this unit out in the field, when you got ductwork and everything attached to it, that's going to be too low. So now you can, depending on how many kW electric heat you have in there and what tonnage unit you're working on with the heat pump, there may be times where you want to separate those. So we can give you the option of doing that. You just separate your red and black wire. So you say you could have red for electric heat. Say you only had a 5 kW, low speed should be adequate for a 5 kW. So you could leave the red wire going to terminal number 6 on that motor, and let's say we needed to go terminal 5, which would be medium speed on the blower motor. We could put that on terminal 5 and separate the two speeds. So when it's in electric only, it would be energizing the red wire and bringing on the electric heat. And if it was heat pump, it would be at medium speed. So this is just a standard PSC motor. And like I said, again, your motor speed selections are done on the motor itself by moving the wires to the appropriate terminals. You got a 3-speed motor. 4, 5, and 6 are the terminals, as you will see from the wiring diagram. Okay, so hopefully you've followed the quick reference data sheet that came with the outdoor unit, and that we've set this blower up inside, like I was talking about a minute ago, with the blower speed settings. Once you've done that, I would hope you're taking it one step further, and you're using a MagnaHelix gauge or a digital manometer, and you are running just the blower inside. You don't even have to have the breaker on outside yet. Just running the blower, making sure that static pressure is within specifications, and that we're moving the appropriate CFM, referring back to the blower chart in the installation instructions. Because airflow of the heat pump system is absolutely critical. Because remember, when you go into heating mode, that indoor coil becomes your condenser. So if we don't get that heat off that coil, that head pressure is going to skyrocket and you're liable to end up tripping out on a high pressure switch. So airflow is absolutely critical. So then the other things with the quick reference data sheet, hopefully you've put the appropriate orifice on the indoor unit, or you have the appropriate TXV on the indoor unit, depending on what that quick reference data sheet specified you needed in there. And out here, we need to make sure we got the right orifice in the outdoor unit also. On the newer equipment now, we're putting the swivel connector out here, and the orifice actually is located right here in the liquid line service valve. Before you put this on here and actually solder your line set to it, we need to make sure we got the appropriate outdoor orifice. Some other things to keep in mind about this service valve. So here we got our high side connection on the liquid line service valve, and we got our low side suction on the extra port that we give you for the heat pump, so you can read suction pressure. Now remember, you can read that suction pressure in heating mode or cooling mode. This is always suction regardless of the mode. That's what I mean by that. So the way these gauges are set up right now, this will only read high side pressure in cooling mode. When you get in the heating mode, if you got your high side gauge hooked here, you're not going to read head pressure because it is after your orifice. So it's actually low side, but it's so close to that orifice, it's not even really a good low side reading. So in order to get high pressure in the heating mode, with that orifice located in this swivel connector, we are going to need to take this red hose right here, and we're going to need to move it to the discharge line here, because this is no longer suction in the heating mode. This line is actually going to be high pressure discharge. So you put your high side hose there in heating mode, and you put your low side hose, you can still leave that on the extra port that we give you. Remember, that's always suction, heating or cooling. Okay, so now that we know where our gauges need to be located, now what we can do is talk about verifying the operation and the charge of the unit in both in heating mode and in cooling mode. When you're out there doing maintenance checks, or if you're doing a new startup, you're not always going to be able to pick the temperature outside. So checking the charge by using a charging chart is going to be best utilized for the temperature you got outside. So we got 3 types of charging charts that come with the equipment. If you got an indoor TXV and you're checking in the cooling mode, you're going to use the subcooling curve chart. If you have an indoor orifice, then you're going to use the charging chart that's referencing discharge temperature in the cooling mode. You could use a slide calculator doing wet bulb and dry bulb. You could use some of the charging apps that reference doing superheat and having the indoor wet bulb temperature. So that's kind of a whole nother video topic, so I'm not going to get into depth with that. But the point I'm trying to make is, if it's warm enough outside, if you're at 70, 75 degrees, we don't want to be checking the heat pump in heating mode to check the charge. You've got way too much load outside on, which now is your evaporator in the heating mode, to effectively check that charge. So what I'm telling you is, if you're checking the charge on a heat pump and you're using a heating charging chart, we want to be doing it below 50 degrees. Okay, so ideally, if you're going to use that charging chart at all to kind of get an idea, is the unit working right, we need to be below 50 degrees. So if you're out doing a PM on existing equipment, or if you're doing a new system startup, you got to use the charging chart that's appropriate to the temperatures that you have. That's the point I'm making. All right, so now we'll talk about the charge for heating mode. So with the FT4BE heat pump, this is referencing your outdoor temperature. It's going to reference your suction pressure, your liquid pressure, your discharge pressure, and your discharge temperature. So, as I said before, when I was pointing at the service valves, unless you put a Schrader core up ahead on that line, you can't get the liquid pressure. But you don't necessarily need to. You get the discharge pressure. That's going to be off your gauge. You can get your suction pressure, and you can get your discharge temperature. That discharge temperature is the one that I want you to focus on. Again, I will also tell you this. Don't use a heat pump heating chart to charge a unit. If you've got a problem with the charge or the unit's not working right, I'm always going to recommend to you that you recover all the refrigerant out of the system and you weigh the entire charge back in, and that way you know that charge is right. Because in the heating mode on any heat pump system, a lot of that charge is stored within the system. You use the heating charging chart just to verify the unit is functioning. Now, I get it. I was out there in the field. I did service for a number of years myself. You know, sometimes, especially when it's really cold, pulling that whole charge out is kind of difficult. So that's not your best avenue. You can use the charging chart to adjust that charge a little bit, and you shouldn't have any issues. And then you come back on a little warmer day, recover all the charge, and weigh it back in. That way you know you got that charge right. In the installation instructions, we reference discharge temperature in the heating mode. Remember, as I spoke to you a minute ago, where your high side gauge is hooking up to that unit, that is your discharge line. Now the installation instructions refers to the discharge line being right off the compressor inside the unit. But I don't know that I'd even go in there unless I absolutely have to. I'd go to the discharge line outside the unit, same place I got my gauge hooked up, and verify the operation of the unit. As long as I'm within a few degrees of that discharge temperature, then I know I'm okay. So the other thing I want you to keep in mind too is that's discharge temperature. So that's before we're condensing. So that's not the same as discharge pressure. Discharge temperature is right off the compressor, and it has a lot to do with superheat. So your low side superheat is just that, just your low side superheat. Discharge temperature is total low side superheat, including the heat of compression. So those two things kind of go hand in hand. So if you've got low discharge temperature, you've probably got an overcharge. If you've got high discharge temperature, you probably got an undercharge. Remember, the compressor is only simply compressing the refrigerant that's introduced into it. So the cooler it goes in, the cooler it comes out. The hotter it goes in, the hotter it comes out. So if an evaporator is starved of refrigerant, when that compressor pumps it, it's already warm going in, and it's going to be warmer going out. That's why I'm saying an undercharge. If you've got really cold refrigerant going into the compressor, a flooding condition, then that would be an instance where you're going to have low discharge temperature and you're possibly overcharged. I mean, there's other things that can affect it too, such as, the evaporator fan motor on the outdoor unit's not running. That's where you're in heating mode, the outdoor unit's running, the evaporator fan's not running. So the thing's just going to frost up and freeze over really quickly because of the fact that you don't have any air being pulled through the coil. So that's one example of where you would get low discharge temperature. So keep that in mind when you're checking the charge on any heat pump system. Before you make any charge adjustments, you need to know and be using the manufacturer's charging chart. One thing I am going to do here real quick is just kind of show you this unit running in heating mode with the heat pump running and showing you that discharge temperature with the thermocouple going down to the discharge line of the unit. Okay, so I got this unit running in the heating mode, and I've got a meter hooked up here, giving me the temperature with a thermocouple running down and connected to the discharge line just like I had talked about. And then obviously in heating mode, this should get really warm, especially with the temperature inside this room, it ought to get really warm. So, and just to kind of give you an idea here, I mean, it's been on very long. I'm at 114 degree discharge temperature. Like I said, this is not the ideal location to be running this unit. It's inside a room, the indoor and outdoor units both in the same room. But I just wanted to show you just briefly. But that's how you would do it if you're checking the charge using the discharge temperature. Just hook your thermocouple on there. So I have a lot of guys that call in, they get confused, and they're trying to charge the unit according to discharge temperature, and they're putting the thermometer on the 3/8 line, which is liquid temperature. Well, that liquid temperature is going to be a whole lot cooler. So make sure we're on the right line when we're checking the charge. Now, if you have a heat pump that has a TXV outside, that's going to be a little different. Now you're going to do subcooling, and we're going to give you a subcooling curve chart for heating mode, just like we did for cooling mode. And then, yeah, you do got to get inside that unit. If you really got a problem, you're going to need to get a thermocouple or a clamp thermometer and get it hooked up to the suction line right by the TXV bulb inside that outdoor unit. and then you're going to take your liquid line temperature on the liquid line just like you would in cooling mode and verify you have enough subcooling, and then also make sure that that superheat is set according to the TXV, and our TXVs are set to 10 degrees of superheat. So that's how you would do it with a heat pump where you have a TXV outside. In this video, we're talking about a heat pump that has an orifice outside. So keep in mind, when you're using charging charts, heating mode or cooling mode, discharge temperature and using that as a charging chart is based on an orifice system, not a TXV system. When you're checking the charge with a TXV, you're going to use subcooling or the subcooling curve chart that we give you. It's a little more accurate because it's going to take into consideration load. So make sure you're using the right chart for the right application. And then when we're talking in heating mode with an orifice, we're talking discharge temperature when we have an orifice, and we're going to be using subcooling and checking the superheat on the TXV if you got a TXV outside. All right, so the next thing we want to talk about is defrost, and make sure defrost is functioning. Most of your defrost boards now are using thermistors. So you're going to have an ambient thermistor, such as the one I have in my hand, and you're also going to have a coil temperature sensor on the coil itself. And the easy way to explain it is, what's happening with the defrost board is it's looking for a differential between the coil temperature and the ambient temperature so that it can sense when it has a frosted coil, and puts it in defrost only when the coil is frosted, so we don't have unnecessary defrost. So checking defrost on a maintenance check, first thing I would do is run the unit in heating mode for a while. In most of your defrost boards, there's a method to advance it in the defrost, such as the hot gas defrost board in the 14 SEER microchannel heat pump. It's just got two little test pins there marked J4. All you got to do is, while it's running, is jump those J4 test pins for a minute, and that'll force it into defrost. And then it'll cycle through defrost and come right back out once the coil temperature hits. So that's a pretty easy test to do, okay? So the other thing you can do, if you're worried about it and think the thermistors might be off, the only way you can really check thermistors is to ohm them out. The best way to ohm out a thermistor, in my opinion, is to take this thermistor and you drop it in a cup of ice water, and then you get the known ohm value, and all of our defrost sensors that we're using in our regular heat pumps are all same resistance value. So at 32 degrees, which is what the ice water is going to be, you would be at 32,654 ohms. So if you took the ambient sensor, this is the ambient sensor off of the heat pump we're talking about, and dropped it in a cup of ice water, you should read 32,654 ohms. If you're off plus or minus about 500, you should still be okay. The coil temperature sensor does the exact same thing. So the other sensor hooked up to the board, going up into the unit, is attached to the coil. Now, would I go in there on a maintenance check and drag that thing out and throw it in a cup of ice water? No, I ain't going to do all that. What I'm going to do is, the unit's been off for a while, or I know the temperature outside, let's use that as an example, then I can look at that same chart that gives me the resistance values for those temperatures. So let's say it's 50 degrees outside. If it's 50 degrees outside, I know I should be around 19,903 ohms, plus or minus 500. So you can use that chart to just kind of see, are you close? Is it shorted? Is it open? Are the wires broke or damaged or anything like that? That's the main thing I would be doing on a maintenance check. Now, the other thing is, okay, you go out on a service call. The unit's froze up. Why did it freeze up? Well, it could be a defrost problem. It could also be a sensor problem. So the first thing I'm going to tell you to do is check the sensors. If the sensors ohm out and that's not a problem, you've eliminated that. Your next step is to force a defrost. And if you can force a defrost and the sensors are good, then more than likely you don't have a defrost problem. You've got a refrigerant flow problem. Whether the unit's undercharged, whether the condenser fan motor, which is now your evaporator fan in heating mode, is shutting off on you, and you don't have enough airflow through the coil, that'll freeze it up. if you got a TXV metering device that's not metering properly and not putting enough refrigerant into the outdoor coil, that'll freeze it up. If you got an orifice that is either the wrong size orifice or maybe the screen before the orifice is partially plugged up, that'll freeze it up. So the point I'm making in this is don't always assume it's a defrost problem. These defrost boards that we're using today as far as defrost goes are very reliable. The thermistors are pretty reliable also. But if I was going to say that either one's going to fail more than the other, I would tell you it's going to be a thermistor. So if the thermistors are good, the defrost board forces defrost, you need to get that thing completely de-iced, run the unit, use the charging chart, and check the charge. Okay, so the last thing I want to cover with you is going out and doing preventative maintenance checks, cleaning checks, whatever your company calls it, on heat pump systems that are out there existing. So when's the best time to do that? It always seems like we get that question a lot. Well, unfortunately, you can't schedule the temperatures to be what you want them to be when your company has time to go out and do preventative maintenance. So we can't pick the temperatures, so you got to adapt to the temperatures. So as I said before, when you're checking the charge and stuff like that, and you go out and do a PM on a heat pump, if it's a 75-degree day, check the charge in cooling mode. There's no reason for you to check that charge in heating mode. The only thing you may want to do is, and you can do it a couple different ways, you can just disconnect the O wire for a minute, let it switch over in heating mode long enough that that discharge line starts getting warm. Stop right there. Hook the O wire back up, let it go back to cooling mode. As far as charging stuff, if it's got the right charge in it for cooling, you got to have the right charge for heating. Now, could you have a flow problem in heating? Yeah, you could, but you're not going to catch that on a 75 or 80-degree day. That was why the importance of what I was telling you before is make sure the auxiliary heat works. Make sure that backup heat works. So we get into winter and it starts getting cold, and at the point where you can actually go out there and see where the problem may be, at least the customer can switch over to emergency heat until you can get out there and do that. Remember what I said earlier in the video is your indoor coil, whether it's a dual fuel application and that coil is on top of a gas furnace or it's inside an air handler, that indoor coil in the wintertime becomes your condenser. So it's absolutely imperative that the airflow is correct. We don't have a dirty coil. Even though that coil might have been dirty for cooling mode, was it cool enough to keep it, or dirty enough to keep it from working in cooling mode? Less dirt, but still too much dirt, is going to be a big deal in heating mode. That's what I'm getting at. So it may be beneficial to you, especially on air handlers. They're not that hard to get to. Is get a look on the bottom side of that coil. Make sure it's clean. Other things I'd be looking at is on the outdoor unit, testing the capacitor. Make sure it's good. Doing a voltage drop across your contacts on your contactor. So if you put a voltmeter lead on both sides of the contacts, you should never read more than a 3-volt drop. You start seeing more than a 3-volt drop, those contacts are pitted, and it's probably about time for a new contactor. Also look for rodents to chewing into the wires and stuff like that. Sometimes you got to really, kill the power and dig around the wires and stuff. I've been burned by that a few times myself. Other things to look at is the cleanliness of the outdoor coil. The cleanliness of the indoor coil we already talked about, but let's make sure that outdoor coil is clean. And we got free airflow through it. Because if we don't have free airflow for it through that coil in the heating mode, now you're going to end up with it froze up, just like as if it was in air conditioner and cooling mode. Dirty coil is going to freeze up. Same thing will happen on the heat pump when that becomes your evaporator in heating mode on the outdoor unit. Other things to look for. The bottom pan of the condensing unit. Something that, in my opinion, is often overlooked. If you got a bunch of debris and buildup in the bottom of that pan, your drain holes are blocked up. So when you got a heat pump going into defrost and all that defrost water is trying to get away from there, if you got debris blocking that from getting out of there before it refreezes, you're going to start getting ice dams in the bottom of that heat pump, which can eventually damage the heat pump. So make sure that bottom pan of that heat pump is clean and free so that the bottom of that heat pump can drain. So the last thing I will tell you is always check the heat pump from the thermostat. What I mean by that is I was always one that did it too. When I was out there, I'd use a jumper wire to control everything. And that's fine. And you still can do that on your PM check. But what I'm telling you is the last thing you do before you leave just go to the thermostat and make sure the thermostat's turning the equipment on and the thermostat's turning the equipment off. So with that, I hope you enjoyed this video. Hope you got a lot out of it. Please submit your questions as we're going to go into the question and answer segment of this now. All right, everyone. So I want to thank everybody for submitting the questions you've submitted. We've already got quite a few good questions in here. But I do have a little help today. You won't see a Dana's video of him, but you'll see a picture of him. But he's going to moderate this for me so that he can read the questions off to me, and I'll answer them as we go along here. So whenever you're ready, Dana, let's go ahead and get started with this.
Okay, thanks, Craig. And guys, don't remember at any time if you do have a question, don't hesitate to ask. That's exactly what the forum is for. Just real quick right off the bat, Nevin asked a question regarding any type of a cost associated with participating in a Lunch and Learn or watching, if you will. And Nevin, just so you know, there is no cost associated with these. These are just purely for educational training purposes, if you will, but no cost associated to them in any way, shape, or form. But we're going to go ahead and get started here. We do have questions coming in, and they look pretty good. So first one here, Greg, is what if the indoor unit has a Y1 and a Y2, and the outdoor unit only has a Y terminal? Which terminal should be used inside?
Okay, Dana, that's a great question. So essentially what we have there then is if you got a Y1 and a Y2 on the indoor unit, but you only got a Y outside, that would be a situation where you have a Nortec unit that's actually a two-stage capable inside unit. And when we say two-stage capable inside, we're talking about the blower's got two-stage capability to it, basically a lower cooling speed and a higher cooling speed. But your outdoor unit, if it's only got one Y connection, then it's going to have, it's just single stage. So very good question, and very important to remember that whenever you're setting up the speeds on the indoor unit, you're setting it for 100% of the blower capacity. So we want to make sure that we're utilizing the Y/Y2 on the indoor unit and the Y outside for single stage, and that'll give you 100% of whatever you set that blower up for. If you use Y1 and Y outside, then what's going to happen is you're going to have the blower running at a lower speed, and you got a single. You're going to end up not having enough airflow for heating and cooling mode. So that was a great question. So whenever you're ready, Dana, feed me another one.
Okay, sounds good. That sounds great. Okay, Greg, so Wally is asking if Nortec requires a heat pump to turn off at a low temperature. And as an example, he's asking if it were minus 10 degrees Fahrenheit outside, should we run the heat pump along with the backup heat strips or just the heat strips alone?
That's a really good question. So do we require actually basically shutting the heat pump down and using the backup heat at any specified temperatures? Okay. No, it's not a requirement unless the equipment's already got it built into it. So what I mean by that is in our higher SEER equipment, some of that equipment, yes, you do have to, the unit will shut down at a specified temperature. So for example, our BG units, the 2018 and 20 SEER heat pump, that unit there will only run down to 0 degrees Fahrenheit outside in heating mode, and after that it's going to shut down and the indoor unit takes over. But it's already pre-set up by the boards out there reading the ambient temperature using the ambient sensor in the outdoor unit. So if we're talking more like just standard single stage and two stage heat pumps and stuff like that, if it's not built into it, which in our single stage and two stage it's not, if it's not built into it, then no, you don't have to, it's not required that you shut it down at any specific temperature. And that's what I was talking about in the video. That's what a balance point thermostat would do. But you can also accomplish the same thing by using a thermostat that's capable of reading the outdoor temperature, and you can set the thermostat up to essentially do the same thing that a balance point thermostat would do. But keep in mind, even though you get down to 0 and -10, you got to look at the expanded ratings and the technical specifications to see, how many watts are you actually getting off of it? How many BTUs are you getting off of it versus the wattage you're burning? So even at 0, you may think, okay, this thing ain't doing anything, but it really is. It might be giving you, let's say, 10,000 BTUs, and for the amp draw you're getting there, so let's say that's 10,000 BTUs, and then you look at the kilowatt equivalent to that and how many amps it takes to get that using like a electric strip heat, it could very well still be efficient even down at 0 degrees, even though you're not getting as much heat. So the heat pump's going to run along with the auxiliary heat is what I'm telling you. So that's what it's designed to do. So you shouldn't really have to shut it down. But if you're in a really, really cold climate, and that's where the contractor needs to kind of look at those expanded ratings and say, you know what, okay, in this climate, yes, I want to actually, when you get down to -10, it may be a benefit in that region to say, yeah, okay, at -10, I don't want to run it no more. I just want the backup heat to take over. Another thing you got to keep in mind, too, is what if you're doing like dual fuel? Well, then you really need to set it up to, there's going to be a certain cutoff that the heat pump's no longer as efficient as the gas furnace would be taking over. So, but no, as far as the requirement, no. Is it beneficial? It can be. So, anyway, hope that answers your question.
Okay, that's great. Great question there, Wally. Great question. Okay, Greg, the next one here that's come in, and I know Tech Service gets this one an awful lot. Why is there a filter dryer shipped with the unit when there's one already installed in the condensing unit?
Okay, so I'm going to be a little careful with that question because it depends on the condensing unit. So in other words, the reason why I say that is if it's a manufactured housing unit with quick connects, the filter dryer would be inside the condenser. If it's a residential style unit with braze-on service valves, then that is not a dryer in there. That is it's a muffler. It looks a lot like a dryer, so I can see where a lot of guys get confused by that. So if it is in the discharge line of the compressor, that's the easiest way to know and look at it and say, okay, that's definitely not a filter dryer. Is if it's in the discharge line coming right off the compressor, in between there and the reversing valve, if it's in that segment of the piping, that is a muffler, not a filter dryer. And nor should we ever take that out and put a filter dryer in a discharge line ever, whether it be an air conditioner or a heat pump, because the problem that you could arise there, and I've seen it out in the field myself, where I've come up on jobs where there was a filter dryer soldered in the discharge line. And the problem with that is if that clogs, you just deadheaded the discharge of the compressor, and that can be catastrophic. So we need to pay attention to where the piping's at. Remember, filter dryers should always be after the condenser coil in the piping. So hope that answers your question.
Okay. Greg, here's another one, and this one seems to kind of be becoming a more of a popular question as we kind of move into the future of materials for heating and air conditioning. But James is asking for any recommendations or tips that we might have on cleaning the microchannel coil on an outdoor heat pump.
Well, cleaning the microchannel coil on an outdoor heat pump, that's a great question. So I can honestly say I've done this myself on the microchannel condensers. I can tell you, I don't think it was a heat pump. I think it was just an air conditioner, but essentially the same coil. Just a hose. A hose and water is really all you should need. You shouldn't need any kind of chemicals or anything like that. Unfortunately, depending on how dirty it gets, it may require removing the jacket around the unit to get in there and clean it. Unfortunately, that's part of it. But if we're doing regular maintenance and cleaning it, once or twice a year, you should be able to just hose it out, and you shouldn't even have to take the outer jacket off the unit to keep it clean. But great question.
Okay. Greg, next question that's come in here is referring to the reversing valve, and the question is the reversing valve energized in cooling mode or heating mode?
So I want to go back probably close to 25 years, maybe a little more than that. I think it's probably closer to 30 years ago, we actually energized some of our heat pumps. We energized the reversing valve in the heating mode. But that was the last time we did it. And I don't quote me on that, but I want to say it was around 30 years ago. So now, from that point on, it's always been cooling mode. We always energize the reversing valve, and cooling mode is done off the O terminal, and it should be energized every time the cooling switch on your thermostat switch to cooling. So a lot of guys misunderstand that. They think that every time it calls for cooling and the unit actually turns on, that's when the reversing valve is energized. That's not true. It is energized off the system switch. So the minute we put that thing on cooling, it should run in, it should be in cooling mode the whole time. And then when we go back to off or heat, that's when the reversing valve would disengage. Another good question, though.
Okay.
All right, keep them rolling,
absolutely.
Dana.
All right. Okay. And okay, so the next question here that's come in is from Bobby, and Bobby's just pointing out that they've had some problems with TX failures, and if we have any recommendations for what we can do to help prevent TXV issues as it pertains to heat pumps.
That's another good question. And Bobby, I want to say this right off the bat. Don't take this as accusation time, because I'm not doing that to you. I wouldn't do that to anybody. But I do know it's happening a lot. When you're installing and soldering refrigerant lines onto the indoor coil, especially if it's got a factory installed TXV, we want to make sure that we're removing that sensing bulb from the suction line before we're soldering the refrigerant lines onto that coil. Because, you know, your torch is getting up to 2,000 degrees or so. Even if you wrap it with a rag, you're not going to hold all that heat back from that sensing bulb. And if you think about it, in the worst case scenario, so even in a dual fuel application where the evaporator coil is in the supply and the gas furnace is underneath it, and let's say the blower failed and it's even cycling on the limit switch, that sensing bulb, about the highest it's ever going to see is a couple hundred degrees, and that's in a worst case scenario. So if we're hitting it with a torch and we're even allowing it to get up to 500 or even 600 degrees, we are putting a lot of pressure onto the power head of that TXV. So when you do that, that bulb is charged with refrigerant, and if we really heat that refrigerant like that, then you can actually put excessive pressure on the power head of the TXV, and it'll actually damage the TXV. So it's extremely important that we're removing the sensing bulbs when we're soldering the TXVs, soldering the refrigerant lines to an air handler or a coil that has a TXV. The other thing to keep in mind with TXVs in 410A is we've got to be making sure that we are purging nitrogen through that system while we're brazing, because if you don't, you're going to have all that scale inside that copper tubing, and that can embed into TXV and actually clog up the screens and affect the needle seat operation of the TXV also. So I'm not going to say that TXVs don't fail, but a lot of the TXVs that are returned, and we get them ourselves, there's times where if we see a spike in the amount of TXV failures, we'll ask for a bunch of them back, and we will send them to the TXV manufacturer. And the percentage of those TXVs that aren't actually failed, that they're full of debris or they've been overheated, is actually a higher percentage than the actual TXV failures themselves, just from manufacturer defects. So, you know, biggest thing, that's the two biggest things I can pass on to you guys. You can't stop a TXV from failing, but what we can do is make sure that we're not aiding in the failure. So, in other words, protecting that sensing bulb, making sure that's not getting overheated, and making sure that system stays clean. So I hope that answered your question.
Yeah, that's a great question there, Bobby, and that's one that comes in quite a bit, and I love Greg's explanation there about, you know, we may not be able to prevent it or stop it, but let's at least do what we know we can to prevent it if possible. So some of the questions are looks like the questions are beginning to slow down now, and that's okay. But don't hesitate. Like I said, this is your forum, if you will. This is for you guys. It's mechanics talking to mechanics here, if you will. So if you have any questions, don't hesitate to ask them. Greg, the next one that's come in is from Ray. And Ray is asking, will the heat pump ever go into defrost if the ambient temperature stays above 32 degrees Fahrenheit?
Well, that's a real good question. The chances of it going into defrost if the ambient's staying above 32 degrees is pretty slim, because at 32 degrees, you've got a whole lot of heat content in that outdoor air. So I would expect your heating cycles to be very short. Now keep in mind, the coil temperature, and being that it's a heat pump and you're in heating mode and you're absorbing heat from outside, your outdoor unit is now got your evaporator. So your suction pressure and your evaporator coil temperature's got to be below ambient in order to be able to absorb heat. So if you're 32 degrees outside, let's say, and I'll throw an arbitrary number out there, let's say the evaporator coil is 20 degrees. So it's still, the evaporator coil is staying well below freezing, so could it frost up? Absolutely. My thought process to that too also is your heat cycles are going to be very short, so in between cycles it's going to kind of thaw itself. Even though 32 degrees, that's not a hard freeze, okay? 32 degrees and 20 degrees, that's a huge difference. So I would think your run cycles are going to be short enough. If it goes into defrost, it's not going to go into defrost very long, and it ain't going to go into defrost very often. So, and I believe the boards, and don't quote me on this because I don't have specs in front of me, I think they completely reset at 40 degrees. In other words, it won't even do a defrost algorithm when it's above 40 degrees. And at 35 degrees is when it stops. So in other words, let's say we had a very basic time temp defrost board. If we had a time temp defrost board and it gets to 35 degrees, so in a time temp defrost board, the way that works is so let's say it's set for every 30 minutes of runtime we get a defrost cycle. In that case, every 30 minutes of runtime we get a defrost cycle. So if it runs for 15 minutes and then the temperature goes above 35 degrees, it's going to stop. And then if the temperature goes below 35 degrees, we still got 15 more minutes of that run cycle before it can actually go into defrost. If it gets to 40 degrees, it's just going to completely reset. So, like I said, is it possible it can go into defrost? Yes. Is it going to go into defrost very often? Probably not. And is it going to stay in defrost very long? No, not at all. So I hope that answers your questions.
Okay. All right. So another question now that's come in. Greg, Bobby's asked another question again, and he's pointing out that they have experienced some issues with new coils, and he's asking if there's anything that they could be doing maybe during installation or during service work on newer coils just to kind of help prevent there being an issue with developing a problem, maybe possibly with a leak or something like that?
Another good question, Bobby. So if you're talking coil failures, I'm assuming we're talking indoor coils. I'm gonna take that assumption. Again, we just got to make sure we're not doing anything to actually physically damage it. If you're talking loose coils, we want to make sure that we're not carrying the coils by the suction line, the liquid line, stuff like that, because that's going to put undue stress on the joints. We want to make sure that we're not doing anything to overheat piping. Other than that, there's really, as long as you're not physically doing anything to that coil that causes it to leak, then no, there's really not much more you can do. But good question.
Yeah, it is a good question. It's a tough question to answer. I mean, there's no silver bullet answer to something like that, but it's a perfectly legitimate question. So Okay, so as our time's starting to wind down here now, Greg, we've got maybe time for just one or two more.
Okay.
And James is asking why the piston connection points and the TXV valve connection points do not use a Teflon seal.
Okay, so on our TXVs and our swivel connectors for the orifice fed coils, that's just the design we've used. We've used it for years, and it's just a brass-to-brass connection. I spent a lot of years out in the field myself, utilizing that same exact fitting, and really had minimal problems with it. The key to that is it's a brass-to-brass connection. You should get a good leak-free connection. The one thing I will advise to you and help you in that make sure we get a good seal. And I used to just use a Zoom oiler that I would use for motor oiling. As long as it's a non-detergent oil, you're not putting it in the refrigerant circuit. But on those brass mating surfaces, put a couple drops of oil on your finger, smear it on those brass mating surfaces, snug it. As soon as it snugs, about another half, 3/4 of a turn, it should be plenty tight enough. Don't He-man it. When you He-man brass, you're going to get imperfections in it, and that's going to cause leaks. So as long as we diligently work with those brass fittings, you shouldn't need a Teflon ring. So that's why we don't use it, because it's been proven many times before that you really just don't need it with that type of fitting that we're using.
Okay, Greg. Well, we really are just about out of time. Only got maybe a minute of time left here. We do have one more question, and that question is concerning dual fuel systems. Is there any type of a recommendation as far as the deadband on the thermostat? Between the heat pump coming in versus the gas furnace, or do we have any kind of a recommendation in terms of degrees, whether it be 2 to 5 or whatever the case may be, something like that?
So you're talking differential between first and second stage. I would, on a dual fuel, I think I'd do at least a degree. I want to force that heat. Well, I don't want to say I want to force the heat pump. But obviously the heat pump is going to be your first stage. So if the temperature outside is such that the heat pump can very easily satisfy the load inside that house, I don't want it to just slip a half a degree and automatically kick the gas furnace on. So if we do about a 1 degree differential, that's going to be plenty, and that'll force the heat pump to do all the heating. And then if for some reason maybe the heat pump's malfunctioning and it's trying to do it but it can't, so we can go ahead and it's not going to let it fall any worse than 1 degree, and then the gas furnace is going to take over. So 1 degree, I think that's what I would go with.
Okay. Well, that's great. Thanks, guys. Those were all very, very good questions. And Greg, that's pretty much it. It looks like the questions have really slowed down now to a point, and you've done a fantastic job answering them. So I'll go ahead and let you wrap it up for today's Lunch and Learn session. Okay.
Dana, thanks. I really appreciate you being a moderator of that. It makes it a lot easier when somebody else is feeding the questions to you. But I do want to pass on a few things here before we go. We got quite a few more Lunch and Learns coming up here real soon. September 13th. I'm sorry, that's today. Duh. September 27th. Tim Alford's going to do Understanding Evaporator Coil Replacement Guide. So on our tech library there, we've with these replacement coils we use, it can be kind of challenged to figure out which replacement coil you need for what application. So he's going to talk about all that and how to read that guide. I think it's an excellent guide. But keep in mind the whole idea of having replacement coils is because we still got to have coils available all the way back to 10 SEER and less. So we've streamlined that by having just a series of replacement coils so that distributors can have coils in stock and on hand and not have to stock all these different tonnage coils. So that's really the whole idea behind replacement coils. So I think that's going to be a great topic. I would definitely tune into that one. And then October 11th, Dana's going to do bad ductwork trumps high efficiency. I think that's going to be another great topic. And then on October 18th, we're doing testing an induced draft heat exchanger. Exactly, what our recommendation is going to be to you guys to how do you determine whether or not the heat exchanger in any particular furnace of ours has reached a point of failure. So anyway, so make sure you tune into those, and we'll see you next time.